Today we're going to talk about the work done by gravitational force. As we talk about the work done by variable and constant force, today we're going to talk about the work done by gravitational force. Now there are the three cases or three situations that happens at the condition of the work done by gravitational force, and these conditions are: just suppose a person is carrying a bag. Now the gravitational force or the force that acts on the bags is downwards, and the direction or displacement covered is forward. So in this condition, the force plus the displacement will act or will become like this. Now this makes up the 90-degree angle. So what will be the work done here? Second condition is that in a free fall moving, let me write here, free fall moving objects comes downwards. Now the force is downwards and the displacement is also downwards. So what will be the condition here? Now just see, हो गया. So that would be angle 1 or 0. So what will be the work done here? And the third condition is that suppose a person who throws a ball upwards. Now direction is upwards, but the force is downwards due to the gravity. So what will be the force done here? First we're going to talk about the first case. As I said, a person is carrying a bag. Now he's carrying the bag and its force is 10 Newton. The distance the person covers is also 10 meter. So what will be the force, what will be the work done here? Now we know the formula of the work done, F into D cos theta. Now as I told you, this will be the direction or the angle of that. So 90 degree. We know that cos 90 is equal to 0. So F is equal to 10, D is equal to 10. Now when we multiply, like 10 into 10 is equal to 100. But when 100 is multiplied by 0, it will become 0. So here we can say that work done at 90 degree is 0. So let's talk about the second condition. Now in the second case, an object is free fall moving and it comes downwards. Force is also downwards and displacement is also downwards. Now let's suppose the force here is 10 and the displacement is also 10. So what will be the work? We're going to just use the formula. Work is equal to F into D into cos theta. Now here the angle is, we can say 0 or 1. So in both conditions, the cos 1 is equal to 1. So we will just going to multiply 10 into 10 into 1. The answer will be 100 joule and 100 joule of positive. So answer is in positive, 100 joule, and that's all about the second case. Now in the third case, it's just opposite the second case. Just suppose displacement covered by object is upwards, displacement, and it just moves from the ground, so the force is downwards due to the gravity. Now what will be the angle of that? Like that, it will be just become like that, and the angle of that will be 180 degrees. Okay, so in this condition, we can take when we just talk about the object or about the gravitational force with respect to the gravity, or Newton's law with respect to the gravity, we just take the D as H and F as G, because we are talking about the gravitational force. And when we just talk about the force or displacement, that is perpendicular, we just call the force G and the displacement the height, because it covers the height. So let's just multiply F into D 10 Newton, same condition, multiplied by, when we know that cos 180 is equal to minus 1. So the condition that we applied gives us the answer in the minus, the negative. So let's just talk about the summary. Force downwards, displacement straight, angle 90, and the work is equals to 0. Force downwards, displacement downwards, that's the best condition, and the answer is in positive or maximum. Force downwards and displacement upwards makes up the 180 degree, and answer is in minus or negative or minimum. Now there are some things that is I think necessary to be discussed. As I just taught you, the D is equal to H and F is equal to G. Now let's talk about this in detail. Work against the gravity. Now work against the gravity is called gravitational potential energy. Now why word potential is used here? We're going to just talk about that. As the condition, for distance upwards, force downwards, make up a 180 degree. Now here in the formula F D cos theta. Now we can just consider F is equal to MA, isn't we? We can. Now here, according to the Newton's law, A is equal to G. So we can just write here the G, and displacement is equal to height as written. So we can just say it height. By cos 180 is equal to minus 1, by multiplying mgh to the minus 1, it will give us minus mgh. And that's the gravitational potential energy. We just call it potential energy because the formula of the potential energy is mgh. That's why we call it gravitational potential energy. We can write minus g or 180, it means same. Like if we just place 180 in the condition, it will be equal to minus 1. Or we gonna just say m minus g and h, it will also give us answer in the minus mgh. So that's the same condition. We can just use these, but we can't use the minus and the 180 at the same time. We have to use the one condition, because minus into minus would be plus, so that will become another condition. So let's talk about something general about it. Now just suppose a body here covers displacement in the round form, in the circular motion. So what will be the work done? The force is 10 Newton. What will be the work done? Now, this condition, the initial point is this, and the ending point is also this. So what will be the distance? Distance will be the 0, because no work or no distance is covered. According to physics, if your initial and final point is same, no distance would be considered. So here at the 360 degree, work is equal to 0. How? F multiplied by 0 multiplied by cos theta 360. That would be 0, because in the condition, if one of the thing in your formula becomes 0, the whole thing will become 0, and that condition or work done will be considered as 0. So distance is same as and work is equal to 0. That's one bullet point. Now there is a situation. Just suppose you are standing in a room that has only one door. Now, you are standing here and you have to go out of this room. Will you go like this? No, you can't, because the room is small. You have to go straight. Now, as we know, displacement is the shortest distance covered. So, the distance and the displacement in this condition would be same. In some conditions, distance is equal to displacement, and as we know, when we are going to just give a general example, we just give the example like that. Now in this condition, distance is more, displacement is less, as written in the second condition. Now in the third condition, distance can't be lesser than the displacement, because displacement is the shortest distance covered by object. That's a condition, or